Hi guys. Okay, so today we're going to talk about direct and inverse variation. Okay, now hopefully you watched the videos. I sent you 3 videos. The Khan Academy video went into a lot of details, and then there was that note video. Okay, but I'm just going to review a couple of things with you to make sure you understand what's going on here. So we're going to talk about direct and inverse variation. Now, basically, for direct variation, y varies directly with x. So when x increases, y increases by the same factor. Okay, so if x is increasing by a factor of 2, y is also increasing by a factor of 2. If x is decreasing by a factor of 2, y is also decreasing by a factor of 2. Okay, so the variation is direct. Okay, and we have an equation that represents direct variation. It looks like this: y equals kx, where k is called the constant of proportionality. Okay, so my k is called constant of proportionality. Okay, all right, so let's give you an example. The cost of burgers varies directly, okay, with the number of burgers purchased. So when you see a question like this, the first thing you want to try to figure out is what's x and what's y. Okay, so the cost is going to depend on how many burgers you purchase. Okay, so the cost that you pay depends on the number of burger. So if the cost is dependent on something, that's going to be my y. Okay, the number of burgers, that's going to be my x. Does that make sense? Yeah? Okay, so here's what we do. It says write an equation to represent the situation. First of all, because it says it varies directly, we know we're starting out with y equals kx. That's my equation I'm starting out with. All right, I know my y is the cost of the burger, which is 45. So I put 45 over here. And k is what I'm looking for. And x, the number of burgers, was 30. Okay, so if I divide both sides by 30, I have k equals 150. So k is my constant of proportionality, but in this case, it's just the cost of each burger. So each burger costs 150. I bought 30 burgers, so I paid $45 for it. Okay, so now, so when it asks for the equation, it would be y equals k, which is 150, x. So when you're asked for the equation, this would be your equation. Okay, and now they're asking what is the price for 20 burgers. So now to find the cost of 20 burgers, you use that same equation, y equals 150 times x, and now the number of burgers is 20, so this is y equals 150 times 20. Okay, and what is 150 times 20? 30. So the cost of 20 burgers would be $30. Okay, and over here is just a graph of my equation. Okay, so that equation gives me this graph. It's a linear graph. Okay, it has a constant rate of change of 150. Yes. Okay, so that is my direct variation. Pretty simple. Now let's look at the inverse variation. For the inverse variation, y varies, and let me use a different color. Y varies, so I have my constant of proportionality k, so it varies inversely with x. So instead of times x, I would be times 1 over x. Okay, so k times 1 is k, so that's how I get y is equal to k over x. Okay, so it varies inversely with x, not directly with x. Okay, so notice we have the inverse of x, 1 over x. Okay, so if you look at this example, the number of hours that it takes to repair a roof varies inversely. So by seeing varying inversely, we know our equation is going to be y equals k over x, okay? And it takes, the number of hours it takes to repair a roof varies inversely with the number of people working on the roof. If it takes a team of 6 people, 12 hours. All right, so how many hours does it take? The number of hours it takes depends on how many people. So number of hours would be my y variable, okay, because it's dependent on the number of people. That would be my x, okay? So I know y is 12, x is 6. I plug that in. So y is 12, x is 6, okay? Then all I have to do is times 6 times 6, and I have k is equal to 6 times 12 is 72. So my equation is y is equal to k, which is 72 over x. That's my equation, okay? And if you graph that, this is what it's going to look like. This is not a linear graph, okay? It's not. It's curved. And if you notice, it never touches this line. It never touches the y-axis, and this line never touches the x-axis, okay? And it goes on forever, but it never touches the x-axis, it never touches the y-axis. So it doesn't have an x-intercept and it doesn't have a y-intercept, okay? And we'll learn more about all of that as we go on. Now, how long would it take 8 people to repair the roof? Now remember, the number of people is my dependent variable x, okay? So x is my number of people. So I use that equation, y is equal to 72 over x, and I simply plug 8 into x. So y is equal to 72 divided by x, okay? And what is 72? I mean, not 72 divided by x. 72 divided by 8. And 72 divided by 8 is 9. So y is equal to 9. So it would take me 9 hours, sorry. It takes me 9 hours to get this done. Does that make sense? So if I had more people, 12 people, it took me 6 hours. When I have less people, I have 8 people, it takes me 9 hours. Okay? All right, so I think I said something off in terms of, I said something off, but I corrected myself. So pay attention to that. Okay, 12 hours. It took 6 people 12 hours, 8 people 9 hours, which makes sense. The more people you have working on something, less time it should take. All right. Okay, and this is just a chart that allows you to differentiate between direct variation and inverse variation. And so you could just fill it in with what we've been saying. Number 1, y varies directly with x. Over here, y varies inversely with x, yeah? And the equation would be y is equal to kx. Over here, y is equal to k divided by x. What else did we say? As k increases, y increases. I mean, as x increases, y increases by the exact same factor. Okay, so x increases and y increases by the same factor. Okay, x decreases and y decreases also by the same factor. Okay, so they're both either going up by the same factor or going down by the same factor. Over here, as x increases, y decreases, but by the same factor. Okay, by the same factor. So if x is increasing by a factor of 2, y is decreasing by a factor of 2. Number 4, this one is a linear graph, okay? The direct variation is a linear graph, as you saw before, and for this one, it's curved. It's not linear, okay? And for the inverse variation, as you've seen, there is no x or y intercept, okay? And I think that's basically it. That's basically it. Right? Okay, and finally, we have the 4 inverse variation practice problems that you were supposed to do all on your own, where it will cost $7.50 per person if 20 people go on a trip. How much will it cost per person if 30 people go on the trip? Okay, so the whole idea here is the cost is dependent on the number of people. All right, so we know that the cost, the $7.50, is going to be my y variable because it depends on the number of people. All right, so if I have y is equal to k over x, and my cost is, my $7.50 cost is the dependent variable because it depends on the number of people on the trip, then my $7.50 would go over here, and this would be k over x, which is 20. Okay, if I cross multiply, I have k is equal to $7.50 times 20, which is $150. So k would be equal to $150. Okay, so I'll erase everything else here just so we'll have enough space. All right, I'll erase everything here. So I have $7.50. So k is equal to $150. So my equation would be y is equal to $150 divided by x. Okay, that would be my equation. And now to complete it, all I have to do now is to say, remember, they're asking you how much would the cost per person be. Now remember, the cost per person is the dependent variable. It depends on how many people are going on the trip. So the cost per person is my y. So that is what I'm looking for. And I have x is the number of persons going on the trip. I have 30 people going on the trip, so y equals 15 divided by 3 is 5. So it's going to cost what? $5 per person. All right? So the more people going on the trip, the less it costs. All right? So I did number 1 for you, okay, just to make sure you understand what's happening.